In this demonstration, we'll cover several oXygen features useful for developing Schematron modules, the use of Content Completion Assistant, master file support, and search and refactoring actions. A common case of using a Schematron modular system is when the abstract pattern mechanism is used. Abstract patterns allow a common definition mechanism for structures which use different names and paths, but are conceptually identical. To demonstrate this use case, we'll use a modular system to define a set of best practice type rules over a table structure. The abstract rules definitions are kept in the abstract patterns module, while the implementations are kept in separate modules, one for data and the other one for XHTML. For our demonstration, we have prepared a project which contains all the resources described earlier. Let's take a look at the abstract patterns module. The first pattern is applicable in the context of a table element. The number of rows is computed, then it is checked that this number falls between a minimum and a maximum value. Note that this abstract pattern defines the following parameters: table and row, matching names for elements defining tables and rows respectively, minimum rows and maximum rows, defining the minimum and maximum number of rows accepted as a best practice rule. The second abstract pattern checks that in the context of a table, the number of columns falls between a minimum and a maximum value. To keep the use case simple, the maximum number of columns is computed as being the maximum number of cells from each row, ignoring cases when a cell spans over multiple rows or columns. The following parameters are used: table, row, and cell, matching names for elements defining tables, rows, and cells respectively, and minimum columns and maximum columns, defining the minimum and maximum number of columns accepted as a best practice rule. Now we'll see how these abstract rules are used to enforce the best practice rules in an XHTML document. To check the number of rows in a table, we define a particular pattern as an instance of the best practice table rows number abstract pattern. XHTML tables and rows are defined using the table and tr elements from XHTML namespace. As a best practice rule, we consider that the number of rows should be between 3 and 20. Similarly, we instantiate the second abstract rule to check the number of table columns. In this case, we verify that the number of columns is greater than 2 and less than 7. Now, we open the data table module. We see that both abstract patterns are also used in the data module to check the number of rows and columns of calls tables. Next, we will edit instances of the two abstract patterns to deal with data's simple tables. First, we will create the pattern that checks the number of rows by instantiating the best practice table rows number abstract pattern. Note that the Content Completion Assistant proposes the abstract patterns from the entire schema hierarchy when editing the value of isA attribute. In this case, we use simple table and st_row for table and row elements respectively. We consider that the simple table conforms with the best practices rules if the number of rows is between 3 and 10. The last abstract pattern limits the number of columns in a data simple table. Next, we'll deal with some problems commonly found when developing Schematron modules. For example, to navigate to the definition of best practice table rows number abstract pattern, hold the Control key and click the abstract pattern reference. Next, we want to rename the pattern BP table rows number to best practices table rows number. If we validate the module, it turns out to be valid. This is because the scope of the validation is limited to the current file only. However, the pattern which was renamed is referred in two Schematron files. data table, and XHTML table, which become invalid because they refer components which are no longer defined. This is the main reason why a module should be edited in a broader context. To help developers achieve this, starting with version 15.2, oXygen implemented the master file support for Schematron schemas. A master file generally means the root of an import or include tree of modules. The master files are defined at project level and are automatically used by oXygen to determine the context for several operations such as validation, content completion, refactoring, or search. To enable the master file support, press the Enable button in the project view. The application displays an information dialog which allows us to determine the possible master files and set them as such. Here, we choose to detect the possible master files for Schematron files. After the detection is complete, oXygen presents a tree with a hierarchy of the files from the project. On the first level, we have the possible master files, which are the Schematron schemas that are not imported or included by other modules. We set the two files as master files. Note that the imported or included Schematron resources are marked as modules. The tooltip displays information about the resource type, its location, and the master files set for this resource. In the last wizard page, you can preview the master files that will be added in the project. oXygen added the selected resources in the master files folder from the project view. So far, we've seen how we can detect and set the master files to define the Schematron editing context. Next, we'll see how oXygen helps you edit a Schematron module in the context defined by their master files. Let's validate the abstract patterns module. The first thing we notice is that now the module is marked as invalid because it is validated in the context of the master files previously set. When a module is validated, oXygen will automatically identify the master files which include that module and validate all of them. Let's correct the errors from both master files and go back to the module to perform another validation after renaming the pattern. To rename a pattern in the context of the current file only, we invoke the rename component action from the Quick Assist helper. Similarly, we'll correct the second master file. It becomes valid after we rename the pattern. Now, going back to the Abstract Patterns module, we invoke the validation action. The module is now valid because both master files are valid. Another benefit of the master file support is the ability to search and refactor Schematron components. Search and refactoring actions, like search references or rename components, operate in the scope defined by the current module's master files. Now, let's rename the BP table columns number pattern. To safely propagate the change in the entire structure, we'll use the rename component in action from the Quick Assist helper. The new name is Best Practices Table Columns Number. When previewing the modifications, we can see that the pattern was renamed in all Schematron documents where it is referred from. And this concludes our demonstration. Thanks for watching.